How's it going, guys? So today we are going to do a video lesson. That means that if you look on the screen, you'll see the note sheet that you are meant to follow along in order to work with this lesson. Today's lesson is 6-3 polynomials, and hopefully by the end of this video, that sheet will be completely filled out. So our objectives for the day are classify polynomials and write polynomials in standard form, evaluate polynomial expressions. First, let's take a look at our massive vocab for this lesson. And as I said, guys, the vocab list here is absolutely enormous. We will be going through each of these, but not in the usual way. You guys are going to need to write down how you understand each definition. Now, let's start from the top. We've got monomial. We've got degree of a monomial, polynomial, degree of a polynomial, standard form of a polynomial, leading coefficient, quadratic, cubic, binomial, and trinomial. A lot of these go together and have sort of the same theme. That being said, each one has its own little place in what we do. Let's take a look. Let's start with monomials. Monomials are numbers, variables, or products of numbers and variables with whole number exponents. The degree of a monomial is the sum of exponents of the variables. A constant, or just a number, has a degree of 0. Let's start with our examples. First, on our monomial side, we have 5x, negative 7xy, and 0.5x to the fourth. On our not monomial side, we have negative 0.3x to the negative 2, 4x minus y, and 2 over x cubed. You notice on the monomial side, there's nothing extra besides a connection between, a direct connection between, I should add, the variables and the numbers. Let's look at the not monomial side really quick to kind of grasp a better vision of this. First, look at 4x minus y. You notice there's a separation there using a minus sign. The y and the x are not directly connected. This is what makes it not a monomial. The next one we should look at is 2x cubed. Why is this one not? Well, that's because it's a division problem. They are not directly connected, therefore they are not a singular entity. They cannot be taken as a single thing. Now, then why did I skip over negative 0.3x to the negative 2? Well, it's specifically because of that negative 2. It would create that fraction just like 2 over x cubed. This would make it not a monomial. Now, degree is specifically talking about the exponent. A constant has a degree of 0, technically. However, a singular variable has a degree of 1. Moving on. Let's start in with some examples. Now, first off, I want you guys to know that these are the examples we do together. However, the examples on your paper may be different. You are responsible for completing those examples. And if you can complete 4 or more, you will get a bathroom skull upon my return. First, let's look at letter A. 4p to the fourth q cubed. That one's kind of funny, q cubed. Now, as we just learned, a degree is the addition of all the exponents in a monomial. Put together, added together, that's our degree. If we look here, 4 doesn't have an exponent. As we just learned, constants, such as 4, have a degree of 0. P has an exponent of 4, so we'll set that aside for a second. Q has an exponent of 3. Now we just add 3 and 4. Well, what's 3 plus 4? 3 plus 4 is 7. Therefore, the degree is 7. Looking at letter B, 7ED. I don't see any variables there. However, as I just stated earlier, a variable without an exponent has a degree of 1. We have two variables, therefore we have 1 and 1. 1 plus 1 is 2. Lastly, c. C doesn't have a variable and it is a constant. Therefore, C has to have a degree of 0, as constants have a degree of 0. All right, go ahead and give example number 1. Let's check it out on a try on your own, and we'll move on next. I'd recommend pausing the video here. Now, let's talk about polynomials for a moment. A polynomial is a monomial or a sum or difference of monomials. The degree of a polynomial is pretty easy. The degree is the term with the greatest degree. That means if we have 7 and 5, 7 is our degree of the full polynomial. Let's take a look at some examples. Now let's take a look at some of our polynomials. First, we have 11x to the 7th plus 3x cubed. Then we have 1/3 w squared z plus 1/2 z to the 4th minus 5. Now, I want you guys to keep in mind that polynomials aren't just 2 or 3 monomials. Take a look, those are monomials. The example wants us to find the degree. Again, this is relatively simple, especially for this first one. Let's look at letter A for a moment. 11x7. 11x7. Now, the x and the 7 are together. The 7 is the exponent of x. We add that to the 11's 0, because constants have an exponent of 0. Plus 3x cubed. The 3 also has a 0. X cubed is 3. We look at which one of these is greater. That will be our degree. In this case, because the degree is 7 and the degree is 3, the degree of the overall polynomial is the greatest degree, therefore 7. Let's look at letter B for a moment. W squared z. We'll cut out the constants from here. W squared has 2, z has 1. 2 and 1 is 3. Z to the 4th has a degree of 4. And -5 has a degree of 0. Because z to the 4th is actually a higher degree, the polynomial's degree is going to be 4. Good work, guys. Go ahead and pause here and give the example on your paper a try. Speaking on standard form for a moment. Standard form is a way of ordering polynomials with a single variable. Now, we can order polynomials any way we like. However, polynomials with a single variable are usually written from greatest to least greatest degree. When we write in standard form, the coefficient or the term at the front is called our leading coefficient. That meaning, let's say we had 4x squared plus x minus 3, 4 would be our leading coefficient as the greatest degree is 2. This is on the paper, so make sure you get this information down. If you need to, pause the video here. On to example number 3. In this example, we have to rewrite each polynomial in standard form, then give the leading coefficient. The example is 6x minus 7x to the 5th plus 4x squared plus 9. We have a total of 4 monomials here. First, we have to find the degree of each. Let's take a look. 6 has a degree of 0. Attached to it is x. Therefore, 6x has a degree of 1 because standalone variables without a stated exponent have a degree of 1. Negative 7x to the fifth has a degree of 5 because 7 has a degree of 0 and x has a 5 as its exponent. 4x squared has an exponent of 2, therefore a degree of 2, and 9 has a degree of 0. Ordering these out, we find 6x minus 7x to the fifth plus 4x squared plus 9 turns into negative 7x to the fifth plus 4x squared plus 6x plus 9. That is because when we look at it, the degree was 1520. It is now in the new order 5210. Something to keep in mind, however. Now we have to look for our leading coefficient. Notice what happened to that 7. The 7 was on a minus sign, but stayed negative. When this happens, guys, when you are moving things around, you can move in any order. However, a number must retain its sign. Always move its sign with it. If we look, the first number you see in the polynomial is negative 7. Therefore, the leading coefficient, or the LC, is negative 7. Good work on this example. Moving on to letter B. This one's going to be a little bit faster. First, we have y squared plus y to the 6 minus 3y. Again, we're going to find the degrees first, and then arrange them in descending order. We have 2, 6, and 1. A relatively easy one is y squared plus y to the 6 minus 3y turns into y to the 6 plus y squared minus 3y. Relatively easy, we only had to switch 2 things. This is because the order was 2, 6, 1. Now, in the correct form, or standard form, it is 6, 2, 1. What about the leading coefficient? Y does not have a number in front of it. Well, as we know, it always has a constant number. If there is no number present, it has a number. That number being 1. Therefore, the leading coefficient of any polynomial without a number in front is 1. Good work, guys. Go ahead and pause here and try the examples on your own. Let's talk about polynomial naming now. Some polynomials have special names based on their degree and the number of terms they have. Let's look at the degree side really quick. On the degree side, we have 0 degree being a constant. We know that because numbers have a degree of 0. A degree of 1 is linear. We can think of that as kind of like our x plus 3s, right? Those may have more than one term and not be a monomial. However, their degree is 1. Therefore, they can only ever produce a line. A degree of 2 gives us a quadratic. We'll be learning about those later. A degree of 3 gives us a cubic. And from there, so on and so forth. Each one having its own purpose in data collection and showing a different kind of graph. Now, as far as the naming scheme goes for nomials or numbers, 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial, and 4 terms is a polynomial. If we look at each one of these, each one should make sense, as the suffix mono means 1, bi means 2, tri means 3, and poly just means many. Polynomials, therefore, have an unlimited number of terms. However, a monomial has only 1. Now, a polynomial can describe trinomials, binomials, and monomials. Or it can describe more. Take a moment to write this list down. The portion to write this list is on the back of the paper at the bottom. Make sure you take a good look at this and copy it down exactly. Now we take a look at example number 4. Example number 4 wants us to classify each polynomial according to its degree and number of terms. We're going to use that chart we just filled out. If you need to, go back, pause the video, and fill it out properly. Letter A is relatively easy. A trick to knowing the number of terms is that you look at the plus and minus symbols. As we only have one plus symbol, we can only be separating 2 terms. 1, 2 on either side of the plus symbol. Now, each of these is also written in standard form, making finding our degree relatively easy. 5n cubed, with 5 having a degree of 0 and n cubed having a degree of 3, 0 plus 3 means we have a degree of 3. So we have a degree of 3 and 2 terms. How do we classify this? Well, if you take a look at your chart really quickly, a degree of 3 means we have a binomial, a degree of 3 means we have a cubic, and 2 terms means we have a binomial. It's relatively weird because the way that this presentation does it, cubic is blue when it should be red. Moving on, however. 4y to the 6 minus 5y cubed plus 2y minus 9. Again, look at the plus and minus symbols. We have 3 separating 4 things. These 4 things are our terms, so we have 4 terms. We can also only look at the leading monomial, 4y to the 6th, to find our degree. As 4 has a degree of 0 and y to the 6th has a degree of 6, 0 plus 6 means we have a degree of 6. We have 4 terms and a degree of 6. Classification is relatively simple, however, the vocabulary can be hard. We have a 6th degree polynomial. There is a word for 6th degree, however, for right now, we will just write 6th degree. Lastly, let's take a look at letter C. Now, there is a minus, however, the minus is not to separate 2 terms. It is to indicate the sign of the number, or the initial term. In this case, our leading coefficient has a sign of negative, and is 2. Meaning it's negative 2. Negative 2x has a single term. The degree is also relatively easy to find. Negative 2 is a constant and therefore has a degree of 0, while x has no exponent and therefore has a degree of 1. 0 plus 1 is 1. They are both 1. In this case, we have a linear monomial. Go ahead and pause here and take a try on your own. On to our last example. Example number 5. A tourist accidentally drops her lip balm off the Golden Gate Bridge. The bridge is 220 feet from the water of the bay. The height of the lip balm is given by the polynomial negative 16t squared plus 220, where t is the time in seconds. The question they ask us is, how far above the water will the lip balm be in 3 seconds? First, we want to substitute the time for t to find the lip balm's height. Go ahead and think only of the t for a moment. And remember, when substituting in, put the number in parentheses. 3 seconds is our time. Therefore, we are going to replace t with 3. Now, only put the parentheses around the 3, isolating it from the negative 16 for right now. The next step is we need to start simplifying. PEMDAS tells us parentheses exponents. Well, we can't really do anything within our parentheses, but we can do our exponent, 3 squared. Keep in mind, 16 is not attached to that square. Do not square 16. 3 squared is, good, 9. Now we have negative 16 parentheses 9 plus 220. We know that any number outside a parentheses set multiplies the numbers inside a parentheses set. Therefore, negative 16 is going to multiply 9. Negative 16 times 9 is negative 144. We are now going to add negative 144 to 220, giving us 76. The conclusion of this is that after 3 seconds, the lip balm will be 76 feet from the water. Go ahead and pause here and give this a try on your own with your example. It's a little bit different scenario, but you should be able to do it. Alright guys, good work today. Remember, this video is meant to help you fill out this form. Keep in mind, I would really like to have you guys get this done on your own. I will go over this lesson slightly, but you are meant to be able to use this video to fully engage with the lesson. If you have any questions, make sure you send me a remind. I'll see you guys later.